All right, so kind of left off talking about monopoly power, specifically and thinking about how that operated in different markets. We then thought about kind of competition of other leagues, and so we'll dive a little bit into kind of switching up gears, dive a little bit more into like game theory. It'll be pretty basic, so almost like a review of stuff we did in 201, but kind of applying it and thinking about how we build out some of these normal form games. So if you've had game theory as a course, this will probably be pretty easy, but we're kind of doing a review. I like to kind of give a taste of this in every upper level course. And so when you think about things like in the NCAA, we've got a bunch of different teams, conferences colluding right under the NCAA in order to maximize kind of profits for the organization as a whole. And so they're really coordinating their efforts. This is almost exactly the definition of a cartel, right? So they'll set prices, they'll set barriers to entry from teams entering. This is a pretty standard kind of version of a cartel. However, it looks a little bit unlike traditional ones in certain ways. So, it's not like the NCAA was formed in order to obtain monopoly power, right? It was more so to kind of regulate kind of the league and ensure player safety, making sure there's kind of a fair, I guess, an equitable playing field. And so it's not like the purpose of it was for, to obtain monopoly power. It also doesn't, its main goal is not to maximize profits. This is typically what we would see from a cartel, right? It's collected these groups and they're going to act as though they're one, and so they can obtain monopoly power, right, to maximize profits for the group. But the NCAA doesn't quite do that, right? It's going to maximize revenues as opposed to profits, right? So it's not so much profit maximizing, it's just kind of revenue maximizing, in the sense that we'll generate as high of revenues as long as profits don't become negative. So we really can push out to the point where profits are equal to zero, which really just means, well, I can always increase expenditures, right? So I can maximize revenue. If I can't keep the additional revenue I earn, right, it's going to be shared with other departments or other kind of areas across the university. All I'm going to do is spend it, right? So spend down to where profits are equal to zero. So when you think about how this might cause some problems, right? So if we think about the NCAA, we have a pretty good example of a prisoner's dilemma. So if we go back to kind of a good example of this, is there was a court case in '84 that found that the NCAA was violating antitrust laws in the way in which it televised games, right? So let me see if I get down here. I believe it was, Oklahoma was kind of originally one of the teams that brought this court case, right? They brought this to the courts. And because basically they wanted more of their games televised, right? And under the current NCAA rules, they were only getting a certain amount, right? A certain amount of their games put on kind of these national broadcast deals, right? Now, the problem is if we make more deals, right? So there's more games available, what happens to the value of each game, right? So this is just the general idea of scarcity, right? If we're seeing an increase in supply, right, that's going to do what to the equilibrium price? Yeah, it's going to lower it, right? And so essentially by adding more televised games, you're increasing that supply curve, pushing down the price that you can sell the broadcast rights for each game, right? So by kind of pushing for these additional games, right, which the court kind of granted, said, yeah, Oklahoma should be able to televise all of its games if the NCAA, it doesn't already have a deal made for them, right? And so when we look at the actual kind of numbers after this court case was decided, the year following the decision, Oklahoma saw TV revenue decrease by 50%. Right? So revenue might have been maximized. Who knows? Depending on where we're at in the demand curve, it could be that revenues went up for the NCAA as a whole, but for Oklahoma themselves, every game that they were previously televising now has less value, right? Because there's just more substitutes available. There's a higher supply of nationally televised games. Okay? So it's kind of backfired on them. So we can kind of think about why this might be the case, right? Well, why, if this was the end result, why did Oklahoma even bring this court case to the courts? So to do so, kind of build one of these normal form games, I'll do a little bit of a quick review, right? So basically, we're trying to determine how we see the market outcomes that we do, or how we see the market equilibriums that we do. Right? And so these equilibriums we'll end up calling kind of Nash equilibriums, right? If we have multiple parties, right, making a decision, and the combination of those decisions or those strategies leads to certain payoffs, right? the point at which both sides, both parties, are best responding to what the other person is doing, we would call that a Nash equilibrium. So if I'm best responding to your action and your action is a best response to my action, we would say we're in a Nash equilibrium. There's no other no other decision that we could make that one of us or either of us would be better off. Whoops. So I always kind of put this, if you guys haven't ever watched Beautiful Mind, this is a great kind of depiction of, there's some good game theory in it. It's also just a generally good movie. But yeah, this is like based on a real person who kind of really developed game theory to what it is today. So the basics, yeah.
So would you say it's like a win scenario, kind of, in other words?
Thinking about like a Nash equilibrium. So it's going to be in its most simplistic form. If let's say that Oklahoma is currently televising, I don't know, half their game or all of their games, right? And there's another team and they've decided to only put on half their games because they know that they can't compete with the higher quality Oklahoma games. And for whatever reason, that's maximizing revenues for both. Televising one more or one fewer games from either side would actually result in a loss of revenue. So we're both best responding to what each other is doing, right? I'll have another better example here in just a second. Maybe it'll make a little more sense. So the general setup that we're going to need though, and I'll kind of keep this pretty basic. So usually we'll just have two players, right? You can have more than two people making decisions, but for most of the models we'll think about just two parties or two players. The timing of this decisions matter. We'll primarily today focus on situations where there's simultaneous decisions being made. And that applies to most of the examples we can think of in sport. We're then going to have the strategies that each player can make. So I'll probably today, I think I'm only going to keep this at two, maybe some other models I'll show you throughout the semester. We might increase the number of strategies a little bit, but for now, we'll just kind of think about each side has two strategies, right? And we might simplify, some real world scenarios a little bit, and then we can kind of imagine what if we included a couple more strategies, right? So we've got the possible strategies they can make, and then depending on what strategies are chosen, the combination of those strategies will result in payoffs to both players, right? So what are those payoffs going to be, or what is the benefit to each player when we see these different combinations of strategies? Okay. So that's kind of the general setup, and we're going to kind of depict these in what we call a normal form matrix, right? So I'll give you an example here, just kind of a visual. So this is like a more traditional kind of economic model where I'm thinking I might have two firms, they're both selling the same product, and they're both, either choosing to set a high price or a lower price. Now, this is kind of one of those simplifications where obviously you can choose a continuum of prices, and you could create like, the right-hand side and, these headings instead of two, just making it high and low, we could break this down to like 10 different decisions, right? Setting $10, $9, $8. We could go even further than that if we wanted to think about exactly like every single cent, what would be the optimal decision. But the same principles would apply. So we kind of simplify just thinking about higher or lower. And then if both firms were setting high prices, these would depict their payoffs, right? And I'll write these out in a slightly different way. So sometimes instead of looking like this, I'll draw out like if I had kind of that payoff of high price, then there's these other ones as well, but just to be complete. Sometimes what I'll write it as, I'll write the first person or the first player's payoff and then the second payoff. So instead of kind of using one of those, kind of splitting it up into two triangles there, sometimes that's a little bit confusing. I'll generally just kind of write out the payoffs separated by a comma. The first player, the player on the left, right, their payoff will be first. Player two up here, firm two, team two, their payoff will be second. Okay? So kind of two different ways of writing the same thing, but it's still going to be the general idea of how we go about and solve these. Okay? So we've got two firms that could set a high or low price, and then we have whatever their payoffs end up being. We don't have any values here, so it doesn't make a whole lot of sense yet. But let's think about, we'll skip through because I want to go through an actual example, and then I'll come back to thinking about dominant strategies. So remind me to do that if I forget. So let's say we've got kind of two competing teams. So I chose some Indiana teams here, collegiate teams, IU and Purdue, right? We're thinking about their basketball program, and they want to televise as many of their games as possible. But if they play at the same day or within the same time slot, they're going to be competing against each other, right? And increased competition, right? We're going to have to split overall demand, or so there might be some issues here. So let's think about what players we have and the decisions they can make. So if both teams choose to televise all their games, they're both going to earn 8 million. If both teams televise half their games, right? So basically coordinate so that they're playing on in different time slots or on different days, then each team would earn 14 million, right? So if we both somehow agree to like only put on half our games because we're not competing with each other, because we can kind of obtain monopoly power for the market for those games, we're going to earn higher amount of revenue. Right? And here, I guess we'll think about maybe instead of revenue here, let's just think about these as profits, because really they should be profit maximizing. But it really wouldn't matter that much if we're thinking about, costs are probably relatively constant, relatively similar between the two teams. And then we have the last kind of combination, which is if one of the teams chooses to put all their games on, the other chooses only to televise half, then the team that televises all their games will earn 18 million because, right, half their games, they won't be competing with the other team, but now half their games, they will be because the other team is still putting on half their games. And so the other team that only decided to televise half their games, right, now all their games, they're facing competition. And so they earn less money, right, 4 million, as opposed to like 8 or 14. So let's kind of build this out, right? Think about what players we have. So we'll do Purdue here, IU up here, right? They can televise all their games or half their games, right? Those are their two strategies. So we'll just write out the two teams, write out their strategies, and then create this 2x2 matrix, okay? From here, it's just a matter of writing in our payoffs, right? So I believe the information we were given, we'll see if I can remember these numbers correctly, was that when they both put all their games on, they were both earning 8 million, and I could write M's next to here if that helps, but it was all kind of a similar thing. It was all in millions. If they both only decide to put half and kind of coordinate to where they were on the same time slots, did I say 14, I believe it was million? Yeah. And then when we have the other combination, if I'm the person who chooses to only put half my games on when the other person puts all of them, I'm only going to get 4 million and they're going to get 18. Similar sort of idea here. If Purdue puts all of its games on, IU only chooses half. Purdue is going to get 18 million, while the team that chose to only put half their games gets the lower amount of 4. So the way in which we're going to solve these models, right, is you're going to go through and figure out what each player, or in this case, each team's best response to all the other person's decisions are. So for the first one, if IU chooses to put all of its games on national television, or televise all of its games, what is it optimal for Purdue to do? Well, if they also put all their games on, they'll get 8 million. But if they only put half their games on, they'll only get 4. So it's optimal for them to choose to put all their games on. What if IU is only deciding to put half their games on? Well, now for Purdue, if they put all their games on TV in response to that, they'll get 18 million, as opposed to if they also only put half their games on, they'll get 14. So to maximize profits there, they would choose the higher value. And then I kind of kept the numbers symmetric, so it's kind of easy, but we would then go through the other team, right? If Purdue chooses to put all of its games on, what's IU's best response? All or half. And here, if it helps to do this in 2 colors, because you'd always have like 2 colors or 2 circles for each player, you could do that. So here, if Purdue's putting all their games on, it's optimal for IU to also televise all their games. And if Purdue is only putting half their games, what's it optimal for IU to do? Put only half their games on. Actually, no. I'm looking at the wrong one, right? 14 versus 18, right? To put all their games on, right? Sorry about that. So I have my best responses identified. Whenever I have 2 best responses in the same combination of strategies, what that's telling me is that each party is best responding to each other, right? There's no, if we're currently in this scenario, neither side can change their decision and be better off. Notice if all of a sudden IU decides to only put half their games on, they're going to be worse off. If Purdue decides to put only half their games on, they're going to be worse off. So we're in a scenario where we're best responding to each other. There isn't another decision I can make that would increase my profits. Okay? Now, what's interesting is that there is a scenario where both of us, if we could coordinate our behavior, could actually increase profits, right? If somehow both teams could agree to only putting on half their games, they both would see an increase, right? 8 to 14 million. The problem is if we are in this scenario, well, now what if IU decides instead to put all their games on, they can actually earn a little bit higher. What if Purdue does the same? They can get a little bit higher. So there's always this incentive to be the one that has more of their games televised, right? And because of that incentive, we end up in what we call this prisoner's dilemma, Nash Equilibrium, where our payoffs, yes, from this point, we're best responding to each other. But if we could somehow agree, right, to collude and only put half our games on, we could actually both maximize profits. So this is just kind of a, deciding, how many games to televise, right? Or how many games to sell the broadcast rights to. There's often like kind of this incentive point, both teams to be putting more games on. You can do a very similar thing with team spending decisions and on things like recruiting, right? Or on facilities, right? Because if I'm the team that spends a little bit more money on recruiting or on my facilities, I'm more likely to attract higher quality players, right? So we both have that incentive. So we both these universities will spend all this money to attract higher quality recruits. Now we're spending all this additional money, but we're both spending it. So we're still in the same position that we are before. We're just as competitive with each other as before. And now we've just spent this additional money and eaten into our profits, right? So there's a very similar model you could build for kind of just spending in general, right? And might see a problem like that pop up on a homework or something like that. Okay. Which I will post the second homework assignment after class today. I hope to get, I don't know if I'll have them all graded by Tuesday. I will try at the latest to have them back to you next Thursday, that first homework assignment. But that second assignment will pop up on Canvas after class today. Okay. And I don't think we'll have covered through everything yet, but you should be able to get a pretty good start on it, at least 2/3 of the way through it initially. All right. Any questions before we keep moving there? I know that you've probably already seen some of these basic normal form games. So I think part of the strategy or part of the skill that I'm wanting you to kind of develop is being able to see something like this and then write it out as a normal form game. It's going to be less likely on an exam or something I give you an actual normal form game, right? Where you have to solve for the Nash equilibrium. It's more of like, I want you to develop the skill of seeing a scenario and being able to build out that normal form game for yourself. Okay. And really it's identifying your two players, your two choices, and then filling in the filling in the payoffs. So I've got another one. And I tried to look these numbers up at one point. They're rough estimates of what the actual scenario was, but you could definitely go out and look at different scenarios and grab better estimates of what the percent of success was. So I don't even remember what year this was now. It's been starting to get further and further in the past. But who was Seattle and the New England were playing? They were on like the 2-yard line or something. Right. And they chose to pass it instead of run the ball. It was a big controversy because they had a great running back at the time. So did they do the right thing? So this is where I tried to go back and look at like what their percentages were during the regular season from kind of a similar standpoint, and then think about what the decision making would in a very simplistic game theoretical kind of way. Right. So let's say that we've got these two teams. So we've got Seattle and New England. So the very first thing we can do, I pop this up over here, maybe. There we go. And I'll blow it up once we kind of work through more of it. I just want to kind of show you how I would do this as I'm working through it. So we've got two teams. We'll go Seattle, team 1, and then New England was team 2. Right? So if the Patriots kind of loaded the box or decided to defend against the run, or they could defend against the pass, right? So I guess, I'm simplifying this a bit, but you're thinking about this as, selecting a scheme that would be better against a run or selecting a kind of defensive scheme that would be better against a pass, right? Now, obviously there's some probably more nuance there, but that's not a far stretch, right? So we're kind of choosing between these options. So think about, and kind of choose from two types of defense. And then Seattle can actually run the ball, or they can actually choose a play where they're going to be passing the ball. Okay? So I've built out my 2x2 matrix. Now it's just a matter of filling in these payoffs. Now here I've got kind of this interesting scenario where this is really a zero-sum game, right? If one person is successful, the other person fails, and vice versa. So if Seattle runs the ball and New England defends against the run, there's a 57.5% chance that Seattle's going to score. Right? So we can build out these payoffs, but we're really just looking at expectations. And you can think about it here. The expectation is if I score, right, the game is over. So you almost think about it as you score, it's like a 1. I won the game. And we're using the value of 1. If I don't score, it's a 0. I get a 0 payoff. So the expected value, which is kind of weird to think about, but this 57.7%, what that's really coming from is like the probability I'm successful is 0.755. If I'm successful, I'll get, huh? Oh, sorry about that. Thank you. Thank you. So, right, if there's a probability that I'm successful is 0.575, and I am successful, like that's a 1. I won the game. Whereas the other probability is that I'm not successful, but if I'm not successful, it's times a 0. So it's almost like we don't really need to worry about this, but that's kind of where that's coming from, right? It's like, it really is just an expected value. It's just that if I win, it's basically just like a 1. If I lose, it's a 0. So we can think about here, the probability they're successful is 57.5%, which means what's the probability that if this combination occurs, what's the probability that New England is successful? It just has to be whatever gets me up to 100%, right? So 42.5. The next combination we have is if Seattle runs the ball, but New England defends the pass, there's an 80% chance they score. So they choose to run the ball, New England defends the pass, 80% chance Seattle scores, which means what's the percent chance that New England stops them and they end up winning the game? The remaining 20%. Then we can just go through the other combinations. So we've got Seattle passes the ball, New England defended the pass, 27%. So this would be 73. Oh, did I look at this wrong? If Seattle passes and New England defends the pass. Yep. Thank you. And then if Seattle passes, New England defends the run, right? That was 72.5. That makes a little bit more sense. Okay. So I've got my payoffs in there. Now it's just determining kind of what the equilibrium is, right? What that Nash equilibrium is going to be. So if I use these, what should I have done? Well, we go through here. If New England decides to select run defense, what is optimal for Seattle to do? Yeah, actually to pass the ball. If New England decides to, run a kind of defensive scheme that's better against the pass, right? What's optimal for Seattle to do? Run the ball. This kind of makes sense, right? If the other, my best response to you choosing a pass-heavy defense is to run the ball. My best response to you doing a run-heavy defense is to pass the ball, right? But it's always best for me to kind of do the opposite. Then if we come down here, for New England, right? If Seattle chooses to run, what is optimal for New England to do? Choose run D. It's always going to be optimal for the defense to choose the defense that matches up with whatever the other team does, right? And then here, if they choose to pass, what is optimal for New England to do? Select the pass defense. So we end up with a scenario where, it's kind of like both parties have exact opposite incentives, right? In the sense that as the offense, I always want to choose the opposite of what the defense does. As the defense, I always want to choose whatever the offense is going to do, right? So we have kind of this kind of misaligned incentives. So we end up with a scenario where there's actually no Nash equilibrium, right? This is kind of like a game of like rock, paper, scissors. You can build out a similar thing, right? It's always going to be optimal for me to do something, right? It's always going to be that there's, you're never best responding to each other, right? Because if I'm best responding to what you're doing, I'm winning. And if I'm winning, then you're obviously not best responding, right? So if I throw, rock and you throw scissors, it's always gonna be better that you would have then changed the paper. Now that you've got paper, it's better for me to change this, right? We're constantly going to be changing our best response to each other. So that's kind of scenario that we have here. So sometimes we see that there is no equilibrium, right? And this kind of falls in line with a dominant strategy, right? So notice here, depending on what New England does, Seattle changes its decision. So we would say that they don't have a dominant strategy. A dominant strategy would be no matter what the other person does, so no matter what IU chooses, it's always optimal for Purdue to televise all their games, right? This would be an example of a dominant strategy. Regardless of what the other person does, I'm always going to choose to put all my games on. And then same kind of thing for IU. So we would call this Nash Equilibrium. In addition to being a Nash Equilibrium, it's also a dominant strategy equilibrium. Right? Any questions on anything I've kind of mentioned or we kind of looked at here? So one thing that you also could say, I don't have an example of it with me, but you can also end up with like 2 equilibrium. It is possible. There's not as many situations you would see kind of in sport like this, but there are multiple kind of Nash equilibriums sometimes that can exist in the game. Okay? So just to be aware of that as we work through some examples. So going here, so I drew this out, right? So the next thing that we're going to kind of dive into, so we're just getting a touch of this game theory. I'll kind of bring it up as we kind of move through topics. I know when we do some advertising stuff, I'm going to bring it back up, thinking about advertising decisions of leagues and teams. So I'll kind of go away from it for a little bit, but I wanted to make sure we kind of went through the basics, did a little review, and kind of looked at how it would be applied to these basic kind of sport examples. So the next big topic we're going to talk about, and it actually kind of lines up with the reading that I had up there for before today, and the one question that was related to it on the quiz, I'll probably end up giving just full credit for, just for you responding, because we'll look at the paper and there are some intricacies, and if we're looking at the conclusions that paper came up with, they might not completely fall in line with what we're going to talk about, but we'll kind of discuss why. So competitive balance, right, is the idea of just, is the quality kind of variation in my teams relatively low? If I have good competitive balance, that means there's not a wide gap in between my best and worst team, right? Or that there's less variation across all teams, right? It just depends on how we want to measure, and we'll talk about some of those measures. So, another word you might see used to describe this is kind of parity. So if we say there's a lot of parity in the league, right, we think about that there's a pretty low range, right, between the highest and lowest quality team, right? There's not as much variation in quality, right? So how much variation does there exist? So what stats can we use to look at variation? I've kind of already mentioned one, which is just the range, right? Looking at the highest to the lowest quality team. What's another measure of variation that we've used, you might have used in 221? Standard deviations, variances, right? Those are going to be really good measures. And we could look at maybe the variation in wins, right? Or win percentages or things like that. So we can use the range, we can use the variance or standard deviation. And I'll probably, remind you the built-in functions that you have in Excel. So, on some of your projects, if you do want to end up doing something with competitive balance, you could kind of come up with those in Excel on your own. So how do we kind of measure this? I already mentioned you can look at wins, the variation in wins, variation in win percentages, but it might not just be that you're concerned with, is there parity in terms of, are most of the games competitive games? If you continually see the same teams winning the championship over and over, you might be concerned about that as well. So even if there's a relatively small range in between my highest and lowest quality team, if the highest quality team is the highest quality team year after year after year after year, I might be concerned with that as well, right? And why might I be concerned with that? Well, one thing that we know, well, I shouldn't say we know, we see play out a lot when we look at different kind of analysis of attendance or TV viewership, is that it can influence the demand curve, right? So the parity in the league or the competitive balance in the league that can impact the demand curve. People generally don't like very predictable outcomes, right? Or they're not as likely to pay as much money for predictable outcomes, okay? So I think here, this is not the paper I gave you. Let me see if I can get this to pull up. I think this is an older paper, if I recall, right? But it's the idea of kind of looking at whether or not, right, in the NBA, when we see that there's like win probabilities that that start to get really, really high. So it's almost like a guarantee that a team's going to win. What happens to attendance? And really what this paper gets at is people do like uncertainty of outcome. However, it's sometimes masked by their desire to see their home team win, right? So they want to see a good game, but they also want to see their team win, right? So there's constantly this battle between the two. But if we were able to ever just solely look at just uncertainty, right? So there was like no home team, right? And maybe actually, I haven't seen anyone look at this, but what would be maybe something in the NFL? What would be a really good example where you could just look at the uncertainty of the game without having a home team?
When they play overseas.
Yeah, when they play in England. I've never seen them look at those attendance measures and kind of, now you don't have a very large sample size because they don't have to play a whole lot of games there. But if you could get these like neutral site games that weren't located near the home city of the home team, it'd be a good way to actually kind of parse that out. But nonetheless, we see it not in sport, we see it across several other kind of markets as well, that if we have some type of competition or some type of thing where there's an uncertain outcome, fans or kind of consumers like more uncertainty in the outcome, right? They don't want to know who's going to win ahead of time. Now it's difficult to do this for leagues, right? If I'm thinking about, I'm trying to make my league more competitively balanced. We talked about when I do things like revenue sharing, if my lower quality small market teams were profit maximizing, when I revenue share with them, what ended up happening? So if I got a small market team that's profit maximizing, I then institute some revenue sharing where they get more than they pay in, what's the problem with that? Either one.
Well, it kind of decentralizes, or like there's no incentive to win anymore because you're, instead of winning as much and earning the profit from the wins, you're earning it from the revenue that you didn't have access to.
Yeah, so this lump sum of money isn't tied to my success, right? So if I only care about profits, what do I do with this additional money? We said they would just pocket it. Yeah, they would keep it, increase profits, and not change their decisions from what they were before. So, there's an issue for the league. If they've got some profit maximizing teams, it's going to be more difficult for them to do certain things to create incentives that would close the gap between those high and low quality teams. Right? So we can kind of relate this competitive balance back to some things we've already talked about, back to differences in small and large markets, thinking about things like revenue sharing, how that could close the gap in wins or improve competitive balance. So it's gonna be very closely tied with that. Yeah.
I was gonna say for like the last question, like I went to the new All-Star game, the NBA game where they put like 100,000 grand whoever wins.
Yeah, maybe you could look at All-Star games or something like that. From what I've seen, the attendance and like viewership isn't as great at those, so you might not get a perfect like thing to use for regular season games. But yeah, you do something like that, right, where you've got kind of two. Yeah, there really isn't a home team, right? Yeah, that'd be good. That'd be another great way of looking at it. Is there anything more I want to say here? So we're thinking about this competitive balance plays an impact on the demand curve. I know obviously like if demand curve decreases, right, we're going to see lower prices, kind of lower revenue. And so that's why teams are concerned with it. Right? So another good example of this, and this is a paper, I think I might have the link, but it really one table summarizes the entire paper. Yeah.
So like as a fan or whatever,
Mm-hmm.
like personally, I'm okay. Like I don't want my team to do that, but sometimes that can come out as like a good thing. So wouldn't we want at some point there to be like a
So you're thinking about it might be good if my team's bad this year because that'll give us increased draft stock that we can potentially be better in the future. So as a fan, you might like the fact, right? But when your team is really bad, would you be willing to pay as much for a ticket as when they're really it's not just when they're bad, right? It's there's two things going on. It's their quality, but also their quality relative to the team they're playing, right? So I guess the analogy would be something like this. So you could look at teams that had stretches where they weren't as good and compare those ticket prices to when those teams were performing higher and like compare to similar quality opponents, right? So it's a good way to think about this.
Jackson Conference. You want to say it, Dave?
Yeah, so maybe, yeah, pick on like the two worst teams, right? If I'm thinking about actually the Pistons are terrible right now. So let's say I've got the Detroit Pistons, right? And they're playing, who else is struggling? We'll go with the Magic. They're pretty bad too, right? So they're both like bottom of the league, right? When they play each other, well, as a Pistons fan, at least I know that could be a good game. At least maybe we could win. So I might be more likely to pay a higher price for that game as opposed when the Pistons play, the Milwaukee Bucks. Right? Not that they're the best team, but right, maybe Golden State Warriors when they're healthy, right? Well, I know the outcome of that game. I don't need to watch it, right? So I am not willing to pay as high a price. So holding constant the quality of the team, if the outcome is more uncertain, right, or I'm closer to the quality of my opponent, it's more likely we see attendance be higher, TV viewership be higher, prices for tickets be a little bit higher. But now, it's controlling for all those factors, right? So it's hard to kind of envision that sometimes.
This might be digging the weeds, but wouldn't, as a Pistons fan, say
Mhm.
Golden State comes to Detroit
Mm-hmm.
and you're used to watching crack basketball, and then all of a sudden Steph Curry is playing in your home stadium.
Yeah.
Wouldn't that possibly increase the prices?
Yeah, so there's probably multiple things going on, right? And so one of the things that we've also seen, there's some research out there on, is if you can hold constant the competitive balance, we also know that opposing teams are more likely to attend, so higher attendance and higher ticket prices for superstars when they come to play. So like, I think there's a paper that looked at Michael Jordan in the 90s and looked at like visiting attendance whenever the Bulls would play there. And then someone just did it with, who did they? I think they did something with like PGA viewership and Tiger Woods being at being there versus not. So we know that there's like superstar effects, right? So that would be playing a role as well. So it is hard to like separate these things out. And really the only way we can do it is if we have a wide variety of variables and use linear regression, because then linear regression can create these thought experiments that actually don't exist. We're just using the variation of the data to say, well, if I was able to hold this constant and hold this other thing constant and hold this constant, but this thing changes by 1 unit, what's the change that we would see in like the attendance or in ticket prices, whatever that variable is that we'd be interested there on the left-hand side. But you're definitely right. That plays a role as well. So this other paper that kind of gives us a glimpse into maybe fans actually wanting some less certainty, right, or more uncertainty. So from 50 to 58, the American League, the Yankees, we're seeing kind of a decrease in attendance, which is kind of wild because they won the World Series 6 times in this time span. So here's kind of a nice little table that really tells the entire story of this one paper, which is if I look from 1950 to 58, notice how many times are they in the World Series? 1, 2, 3, 4, 5, 6, 7, 8 of the 9 years the Yankees were in the World Series, and they won it 6 of those 9, right? So really what we have here, right, is it maybe that it's not just variation across the league, but maybe we want more turnover at the top. If we keep seeing the same, like, look, if I'm watching baseball in this time period, like the World Series is probably not as entertaining of a game, or the AL championship, because I already know probably who's going to win, right? And so what you notice is if we look at Yankees attendance, after they start kind of building this dynasty, it just starts decreasing. And it kind of levels off here, right? But even in this last year, it decreases again, right? And just American League attendance. So this was home Yankees games, right? But maybe when they're on the road, the visitors also attend the game less because they already know the outcome, right? If the Yankees are that much better than every other team. And so if we look at AL attendance, notice in those initial years when they're building their dynasty, drops quite a bit. And then the year that they lose and don't make it to the American League championship, that's actually when it went back up, right? So you can kind of just look at the trends here and get an idea that Yankee and American League attendance kind of took a dive during this time period. But notice what happened in National League attendance. It went down a little bit here, right? But then it really starts increasing dramatically because we start seeing a lot of different teams kind of in there as the National League kind of champion. We can't really see that from this table, but like, because it only shows the AL champion. But here it was like there was less turnover in the National League teams as opposed to up here. I mean, we have multiple National League teams even winning the World Series, right? So we can kind of look at how there was probably, less competitive balance in the American League, more in the National League. And then we can see that the attendance numbers in the National League as a result were higher. Now, this isn't like a perfect study, right? Like we would want to control for a bunch of other factors, maybe do game by game analysis, but this is kind of a nice glimpse to kind of see this relationship between attendance and outcome uncertainty. Okay. So we've already talked about teams and their market size, and kind of thinking about this as a combination of a variety of things, but generally population, average incomes, metro area population. And so, a lot of the times when we look at this, if you just go out and grab city population numbers, it doesn't really have areas ranked correctly, because the city itself, right, could be smaller or larger, right, if we're comparing two different cities. But if the smaller city has like a metro area 10 times as large, well, their consumer base for a team in that city is going to be much larger, right? So a lot of the times we want to be careful and probably rely a little bit more on metro population as opposed to the city population, right? For thinking about kind of in this broadcast area, it may not necessarily just be kind of a city or metro area that has a huge population. So one team I can think of that has a very large, like I would say their market size is one of the largest, despite the actual city they're located in not being large, is if we start looking at college teams, right? So like Notre Dame, for instance, they are in South Bend, Indiana. That is not a very large area, but their fans are national, right? They have such a long history past, right? And that they really have a national consumer base. And so there, right, because of being able to broadcast their games on NBC for however long every single week, right, they were able to increase a lot of fans, even though the actual city or market that they're located in isn't large, right? So sometimes it's hard to get a good measure of what their actual market size is, right? But for the most part, it has a pretty high positive correlation with city size, right? City size, city average incomes. So the question becomes, do we want perfect parity, right? So do I want perfect parity in the league if I, as a league, am trying to maximize profits? So think about it this way. If I sell, the rights to broadcast a New York Knicks game, versus the same team, so New York Knicks versus, we'll say, LA, or I can broadcast, Oklahoma City versus LA, and assuming that we have quality differences across these teams, like all these teams are the same quality, the game where I've got New York versus LA, I can sell for a much higher dollar amount, right? So my large markets are always going to be able to generate a little bit more additional revenue. So when I'm thinking about the revenue that's coming per win, as the league, what teams do I hope have the most success in my league? Well, the marginal revenue associated with a win, we just think about it, right? So we've looked at these before. Let's say I've got my wins, and I know that here's my demand and marginal revenue for my small market team. Here's demand and marginal revenue for my large market team. Right? If I think I drew this probably too extreme, well, I can just really draw it like crazy. Right? So let's say, I don't know, we're looking at, I don't know, if they both win 4 games or something, right? The marginal revenue that comes from that winning that 4th game from a small market team is significantly lower than the marginal revenue that comes from that 4th win. Hold on, I lost my train of thought. The marginal revenue that comes from winning that 4th game for a small market team, much lower than the marginal revenue that comes from winning that 4th win from a large market. So the leagues are going to want their most successful teams, if possible, to be in the largest markets, right? So they don't necessarily want perfect parity, right? They don't want everyone to win the same number of games, because if everyone's winning the same number of games, right, I know that I could kind of sacrifice some of the small market wins. So maybe they go back to like 3, and large market kind of goes here to whatever, 5. Right. And even though I gave up a little bit of revenue here, I more than made up for it with this additional revenue earned in my large market. Right? So because we have that difference, here, let me zoom out a little bit so you guys can see all this. because we have that difference, right? They're always going to want their large market teams to perform a little bit better, right? We want some parity, but we don't just want complete parity, right? Because then we're kind of sacrificing revenue from these large market teams and earning less revenue from these small market teams winning. Okay. Any questions on that? I probably should have drew this as a dashed line, but I'm just kind of trying to make a point at the same number of wins. So we don't really want complete parity, right? And if we have any disparity in our league, we want it to be that the large market teams are performing a little bit better. Okay. I've kind of already said this. Any questions there before we keep moving? So I want my large market teams to be a little bit better. So how do I start measuring maybe this competitive balance in the league, right? So within a specific season, we can just look at the standard deviation and win percentages, right? And if we look at kind of the difference between the mean will always be 0.5 because there's always well, I shouldn't say always, because we could see ties. So we'll think about like an NBA for right now, because we don't see ties there. But in a league where we don't have ties, we know that mean win percentage will always be 0.5 because someone loses, someone wins. Now, if we factor in ties, it gets a little bit trickier there. You calculate the mean win percentage. It might be a little bit different than 0.5, but then it would be the same sort of setup, right? Take every team's win percentage, the deviation from the league's average win percentage, which, like I said, if there's no ties, it's always going to be 0.5. Square each one of those deviations and then add them all up. Right? That was kind of the procedure for finding the variance. We then divide by n. Well, n is going to be our number of teams here. And then if we want the standard deviation, we have to take the square root, right? Just a square root of the variance there. Okay. So if we look across the different leagues, and I took some old data because I had some old data and it doesn't really matter what year we're looking at. In fact, maybe I'll bring in some data next week because I've got a bunch of other time periods. We can actually see what's happening over time to competitive balance in these leagues. So Major League Baseball has the lowest, then NHL, NBA, NFL, right? So what's one issue when we're looking at these standard deviations is that we're not comparing. So it's kind of I think maybe something that doesn't get talked about in 221 or is a little bit glossed over. But if I have a different number of games being played here, what's going to, because we have a zero-sum game where someone has to win and someone has to lose here, if I get a higher number of teams, that's inherently going to decrease my standard deviation. Right? So if I'm having a higher n, a higher number of teams, even if I saw the same deviation of each team from that mean, I'd end up with a higher standard deviation measure, lower standard deviation measure here when I had a higher number of teams because I'm dividing by a larger number. Right? So we know that if we thought about even if a league that it was in perfect, I shouldn't say perfect, let's say that was as close, that every team was behaving in a way where all the quality, the quality differences across every team didn't exist. But there's just going to be some natural variation that exists in who wins, who loses. So we can think about maybe there's this ideal standard deviation. And that ideal standard deviation will depend on how many teams are in that league, right? So which one of these leagues has the most games? Well, the MLB has 162. That denominator is going to be significantly larger than the NFL, who has 16 games, even though they have the same number of teams, right? And I said number of teams here. This won't be the number of teams. It's going to be the number of games being played. Sorry about that. So if we go into this, right, why might it be so much lower? We've got way higher number of games in Major League Baseball, and you can actually come up with the ideal kind of standard deviation, which is just going to be that every team is winning half their games, losing half their games. But then because we know the number of games is going to influence kind of our standard deviation measure, we'll divide by the square root of G here. And G is the number of games being played. Okay? So we can come up with this ideal standard deviation measure and then come up with a ratio, of what the actual standard deviation is relative to the ideal, right? And so generally this will be above 1 because the actual standard deviation is going to be higher than the ideal standard deviation, right? Ideal standard deviation being if it was a perfectly competitive or a perfectly balanced kind of league, right? So perfectly balanced, that ratio would be 1. Anything that's more, imbalanced, it's just going to increase larger and larger and larger. Okay. So we can look at those original, if we go back to the other slide, I had those original standard deviations for each league. I can then come up with the ideal standard deviation for each league and then take the ratio of the two. Now we can kind of see that actually the league that is the most imbalanced, right, or out of balance would be the NBA. And then for the NFL, I don't think this is 2011 either. I think it's the same as whatever year I said here. Yeah, it's 2016. That must be a typo. But you can kind of see here that NBA is the highest in NFL, although it looked like they had the most. Looked like they had the most variation. Once we account for the fact that they play a small number of games, right? That ratio, they actually end up having kind of one of the lower ratios, right? Them in the NHL. So once we have this ratio, that's going to really be the measure that we want for how balanced the league is. Which is interesting. I see like a lot of these papers, even some we'll look at today, use things like win percentages, and I would, I would be interested to see if someone did something with these ratios, if they would get some slightly different results. Oh, maybe this was 2011, and then I wanted to show the comparison to 2018. I forgot I did that. So kind of prior to the pandemic and some weird things going on, kind of see just the gap in this 7-year time period. That the NBA has gotten a little bit better. Major League Baseball, NFL, NHL have all gotten a little bit worse. So they're all kind of approaching maybe a more similar ratio. But, slight changes year to year. So if we think about competitive balance, there's something else that's going to kind of play a role, which is diminishing returns within positions. Right? So one thing that helps improve competitive balance is leagues where you see extreme drop off in the marginal returns or right, the marginal production within the same position. So this would be the idea. If I'm thinking about quarterbacks, right? Let's say I get the best quarterback that's in the league. I spend a huge amount in their contract. I then go out and sign the second best, right? That way I keep them off of any other team and I spend this huge amount of additional money. Well, the marginal benefit of that second quarterback, they're never really going to play. So the only benefit is that I'm taking them away from another team. Right? Whereas if you think about a league like Major League Baseball, right? I can have 3 or 4 pitchers and each one of them is highly productive and plays just same number of games as the very first pitcher. The third pitcher pitches just as many games as that first quality pitcher, right? So in that position where I don't have that marginal product or the marginal kind of number of wins that player is adding fall very much, well, it makes sense then for a team like the Yankees to go out and sign the best 3 or 4 pitchers because they're all going to be highly, highly productive on the team. Whereas you don't really see any, NFL team go out and, sign one of the top 5 quarterbacks if they already have a top 5 quarterback, right? It just doesn't make sense, right? They're not going to increase your number of wins by anything. If maybe a little bit from decreasing the quality of opponents, but that's assuming that quarterback would even be, on our schedule that year, right? So these diminishing returns in the same position, by thinking about, and I think I had an older example here now, maybe we should change this because I don't know who wants to sign Cam Newton, right? But if we had kind of think about 2 high quality quarterbacks, right, we wouldn't see a team spend near, the amount of money that second high quality quarterback command because there's just no additional kind of wins that are added. So, think about kind of, the marginal win per dollar would be very low for that second quarterback. Okay. So marginal kind of diminishing marginal returns kind of ensures that, we don't see teams stockpile, right? And that we get a little bit more of kind of equal quality dispersion across these teams. And I think I already mentioned, baseball, you can kind of imagine stockpiling. There might be a little bit more, right, incentive to do that because at least within that position, the fall off is not very great at all. Maybe they get an extra 1 or 2 games pitched on the whole season, that first pitcher, but that your second or third pitcher are pitching just about, if not as many games, right? And so they can be just as, the product. I'm always going to sign the best pitcher first and the second best next, but that drop off is going to be very slight. as opposed to kind of when I have to have a backup player, right, sitting on the bench. Okay, any questions on that before we keep moving? Just trying to tie in some of these old things we've talked about and think about how they influence this new idea. So another thing that we can do is look at between season variation, right? So we can look at within one specific season, what was the competitive balance, but what about across years, right? Because I really need to build a product, right? This is like going back to that, the 50s, right? With the Yankees, I don't want to have kind of no turnover at the top as well. So one thing that we could do is look at standard deviation or variance measures of a team, one specific team over time, right? Or we could kind of look at the standard deviation or the variation that exists in those standard deviations or those ratios year after year, right? So you can imagine if I go back and for the NFL, I calculate what their ratio is for the last 20 years. I could then say, okay, across these 20 years, what has the variation been in that standard deviation, right? So how much variation is there in the kind of this measure that we're using to, kind of proxy for competitive balance, which is the standard deviation in each year. We could also do something like, build kind of a HHI, right? So the Herfindahl-Hirschman index. Generally, we think of doing this to like measure monopoly power or if there's oligopoly power, and we look at kind of market shares, right? So all we're doing is adding up the market shares kind of squared, right? Well, here our market share, what we're going to use is going to be the number of years that a certain team won the championship divided by the total number of years. So this would be something like, in the last 20 years, so N would be 20, right? Maybe we have one team and they've won one championship. So their kind of share of championships, and as opposed to market share, it's like the market share of championships would be 1 out of 20. So we 1 out of 20 squared, then go to the next team. Well, they won 0. Okay, so 0 out of 20 squared, add that to it. And the next team, well, they won 3. So, okay, add that 3 out of 20 squared. And we just go through every single team and add up these market shares of championships, right? So that would give us kind of a measure of how much variation there exists, and in a way, how much variation there exists in kind of the market share across these, how much of it's concentrated within these small number of teams, right? So the higher the HHI would represent kind of a more imbalanced league in terms of kind of championship turnover. Any questions on that? So I think it's it's relatively not too bad. You can also, if you want to, like, you're really just scaling it, but instead of using the proportion, right, the number of championships out of the total, you could then multiply that by 100 so that you're using like percent market shares. It really doesn't. And I don't know if we do that. Let me see if I can show you here. So there's really 2 ways of doing it. So if I do the market shares, I'd have something that looks like this, right? Et cetera, et cetera. Okay. So usually if we do an HHI this way, at the very end, we then multiply it by 10,000, right? Because otherwise you can imagine like 1/20 squared, we start with some really small fractions. So then multiplying it by 10,000 usually looks a little bit more presentable, right? Now, what you can also do, as I said, turn all these proportions into percentages, which is really just multiplying them by 100. So here it would be like 100 times 1/20 squared plus 100 times 3/20 squared, etc. Right? And these would actually give you the same value. And notice why it's like 100 squared is 10,000. So multiplying everything by 100 before you square it, using market percentages as opposed to like market proportions, you'd end up with the same thing, right? It's just that when you only use the proportions at the very end to kind of translate it into something that looks a little bit more presentable, you'd have to multiply it by 10,000. Okay. But either way, right, it's really just if we're comparing leagues or if we're just getting a measure, the higher the measure, it always represents kind of a more imbalanced league. Right? All right. I think we'll kind of take a step back. So we'll look at this. We'll look at Lorenz curves and variance principles on Tuesday. No, I still want to do this. I just want to exit out. There we go. We'll take a look at the paper. So I think the one that I gave you guys was the MBA one, right? Yeah. So kind of this paper is trying to get at kind of whether or not uncertainty in outcome actually leads to a increase in attendance, right? So they call this kind of the uncertainty of outcome hypothesis. And if we read through their little abstract, the model reflects aggregate attendance, blah, blah, blah. The outcomes of attendance are associated support the key findings of the model. So, you know, think about kind of what should be, I think that they're a little misleading in this, where they say that it lines up with the predictions of the model, because the model predicts that attendance will go down when we see, more uncertain events. But they really have a lot of things going on, and they complicate it and they interpret it as though it lines up with that hypothesis. So we'll scroll down here, kind of see what they did. So I see an equation. Okay, they're just talking about utility functions. So I keep scrolling down. I want to find my regression equation. Keep going, keep going. I know it's in here. Here we go. All right. So I've got this regression equation where y is going to be attendance. Okay, so my dependent variable here, or my variable I'm thinking about on the left-hand side, is going to be attendance. Okay. And then tell me, okay, x is a vector of time varying care. So a vector just means like it's like a column of, or they have all these other things that they're like trying to hold constant. Right? And we'll look at what some of those are. SP is going to be the main kind of thing we're going to focus on, which is the point spread of the game being played in between the home and visiting team. Right? They've then got some other characteristics that they hold constant. They've got some home team characteristics, et cetera, et cetera. This SP is going to be what they end up using to proxy for how uncertain the game is, right? So I got another paper, if we have time, we'll look at, they use something like win probability, right? How likely the team was to win the game going into it. Well, here, that should be reflected in betting lines. So we'll do a little bit with some betting stuff in this class. And I'll actually would suggest, if you still haven't come up with a project idea, one that could be good is something like this, where you're using the point spread to be kind of your measure of how certain or uncertain the outcome of the game is going to be. But those betting lines are always, they're trying to set them so that when you bet on the game, it's a 50-50 split, right? So it's a 50% chance that the team covers the spread, 50% that they don't, right? And when they set a spread, so they'll do something like you've got two teams playing, and let's say the one team has a point spread of +5, right? So that means there's a 50% chance they win by, there's a 50% chance that they lose by more than 5 points, or a 50% chance that they lose by less than 5 points or win the game, right? It's kind of like there's a 50% chance we're on either side of this thing. So if this thing, this point spread gets closer to 0, right, then that should mean I have a more uncertain outcome, right? That this game is going to be really close. We're not really sure. If the point spread was 0, that means there's a 50% chance the team loses, 50% chance they win. Now, they don't ever set those, or very, not very often do they set a line like that, but that's the idea, right? So they're going to use this point spread as a measure of how kind of going into the game, how much Las Vegas or these companies that are setting betting lines, right? How much they thought the one team is going to win or lose by, right? How mismatched they believe the game was. So we scroll down. They've got a bunch of other variables. They're also going to kind of build in this idea of distance. And so that maybe attendance, if a visiting team has to travel further, right? We're not going to see the same attendance measures regardless of what the uncertainty of the game is. So we keep going down, find the next table. So this is where their regression results are, right? So for every additional point that the point spread increases by, right? And we're going to ignore this first column for a second because I don't know why they did this, right? So they're only going to look at games where home teams were favored. Because once the home team is favored, if they're favored, that means that you're going to get a negative point spread. So that they think you're going to win, and they're trying to get people to bet on how much they think you'll win by. So if it's -5, that means that you have to win by at least 5 or more in order to cover that spread. Right? So there, when I have a point spread that's negative and the home team is favored, then an increase of 1 point actually means becoming more uncertain, right? I'm getting closer to that point spread of 0. So when that's the case, what they actually find here is that getting closer to 0, having a more uncertain outcome, we actually see a decrease in attendance by about what, 53 people, which might not seem like much, but we could think about a point spread closing by several points, right? And it is significant, right? So we get 1 star, which means that, we could say that this relationship has, is statistically significant at the 10% level or with 90% confidence. Right? Say that again. Oh, you are right. So they did not use the convention. They only showed us what's significant at 10 or at 1%, right? Usually 1 star is 10, 2 stars 5, 3 stars 1. Here, I guess everything was so highly significant, they just chose to do 1 star, right? It looks like everything they have here. Am I missing? This is significant. This is. Yeah, everything they found was, and that's because it's a lot easier to find statistical significance when you have a lot of observations. They had a huge number of observations here, right? We go back, so they've got 34,000 games. It's pretty wild, right? And then kind of break this down. The other thing I wanted to look at was they start to do something like use these interaction terms. So these are kind of valuable, and I think it's worth kind of discussing what it means when we throw an interaction term into a regression. Okay. So this kind of goes, first of all, goes against this uncertainty hypothesis, right? Because that last column I showed you, there when a game was becoming more uncertain, we actually saw a decrease in attendance. That's not what we would expect. But there's likely something going on with the fact that the home team is favored, right? Fans want to see their team win. And so this is where it would really be ideal if you could somehow get a scenario where you don't have home versus visiting teams. You have like a neutral site game, and there you're thinking about how the uncertainty of the game would play a role. So they start to build some other things in that they think might be explaining this, like the distance that the visiting team is from wherever the home team, home game is being played. And I then interact that down here with, visiting or home win percentage, right? So think about the home win percentage one, because that one's a little bit interesting. Okay. So here, if I've got attendance, and I'm thinking about it's a function of distance, the quality of the team. Let me make sure that's what that was, right? They were interacting home win percent. Yeah. And then I include the interaction between these two, right? So distance times home team's win percentage. Okay. This interaction term is going to tell me the additional change in attendance from being 1,000 miles away for a different team or a team with a higher win percentage. Right? So you can think about here, if I'm holding constant the win percentage, but I go up by the distance between the home and the visiting team is 1,000 miles more. Well, I know that probably being further away, right? A 1 unit increase, well, distance here is being measured in the thousands. So 1 unit is if I'm 1,000 miles further, right? The visiting team is 1,000 miles further from the home team. We would expect attendance to change by whatever beta 1 is. So what do we think beta 1 probably is? If I get 1,000 miles further from between the home and visiting team, what do you think was likely to happen to attendance? Well, visiting fans probably aren't as likely to attend. So if we look at the actual regression output here, so we don't get negative, but we get that we do have negative here. Oh, it's because they're including in the interaction here as well. But you can kind of see it's negative. But maybe it's not just purely the distance, right? Maybe distance, like it doesn't matter how far away it is, if I think that I'm going to get to see a good quality team play, or I'm going to get to see a high quality game. So when they interact that distance variable with home win percentage, you can think about now, this is the effect of distance independent of the quality of the team that I would be traveling to go see, right, as this visiting team. So now what's the effect if distance goes up by 1,000? Well, it wouldn't just be beta 1. it would be beta 1 plus beta 3 times, right? So if this goes up by 1,000, it'd be beta 3 times whatever the home team's win percentage was, right? So there's this additional effect that comes from being 1,000 miles further away that depends on what the home team's win percentage was. So if the home team's win percentage goes up and the kind of distance, what would we think maybe the additional impact would be? Well, if they're a higher quality team, maybe I want to go see a good game. And so maybe I'm thinking about this is going to be positive. So if we look over here, I end up with this negative value. Right? So what that is maybe an indicator of is that it's not that fans are going to travel to see just a high quality team, right? If that high quality team makes it so that they're more likely that their team is going to lose, I'm not going to travel, having to travel an additional 1,000 miles for a higher quality team where my visiting team, is more likely to lose, I'm less likely to attend that game. So because we end up kind of seeing beta 3 be less than 0 here, that's telling us that, right, the additional kind of effect of being further away, right, is going to the additional effect is going to be from moving distance, moving another 1,000 miles away from the home team is going to have a larger impact when that home team is a higher quality team, right? They have a higher win percentage. Okay. So that's how we can start to interpret kind of these interaction effects. Now, usually I would probably give you or kind of show you things where interaction effects where one of the variables is just an indicator, and that makes it a little bit more easy to think about. So here they kind of kept 2 continuous measures. Usually we'll think about kind of an indicator there, and that way it's just like the additional effect of moving 1,000 miles away further if the team belongs to this category versus not, right? A 1-0 variable being the other variable that we interacted it with. Here they kept it continuous. So I don't know, kind of an interesting result, kind of goes against some of the conventional wisdom. And they've got some other stuff where they start to parse it out. We'll kind of talk about right now. But the other one that I wanted to kind of go over, it's very similar, so we don't have to change too much. So we'll scroll down here. We've got, here we go, summary statistics. So here's my regression equation. They're going to do a similar thing, right? But they, instead of using this point spread, have an actual win probability measure, right? So now it's a little bit easier to think about because we're not dealing with negative point spreads and getting closer to 0. It's just a win probability measure, right? And then here's they use something called the natural log. We don't have to worry about that for right now. Just think of this as TV viewership, right? Kind of some type of TV ratings that they have. And they've got a bunch of other controls, right? For, whether or not it was, on television, who the away team was, who the home team was, year fixed effects, all these good things. So we'll scroll down and look at their results. So it looks like when the home team is more likely to win, that TV viewership goes down a little bit. So this is more in line with that uncertainty outcome hypothesis, right? That when home team win probability goes up, viewership goes down. Now, they included this squared component, which up to this point, we've only looked at linear relationships, right? So we'll kind of ignore this squared component for today. Next week, I'll use another paper that has kind of a quadratic, and we'll spend more time talking about how that quadratic can pick up nonlinear relationships. But the idea here is I want to show you, because we do see negative results here. So when the team is more likely to win the game, we actually see less viewership. And they also, this was European soccer, and I'm not as familiar with all the terms, but they controlled for like 2 clubs that were like really good. I forget who they, Real and Barca. I guess those, if we looked at the attendance measures, they were just so much higher because those teams were high quality that they had to include indicators for whether or not the game had one of those teams playing. But once they did that, you can kind of see they're always kind of getting negative results there for if the home team is more likely to win, right? Or the outcome is less uncertain, we're actually seeing fewer TV viewers, right? So maybe there's some things going on with attendance, right? Actually attending the game that wouldn't be with TV viewership. In fact, anytime you want to do something with attendance, this kind of goes for your projects as well. Well, that first paper kind of did something that's not great. But I'm just looking at the number of people. What's one thing that might kind of be hurt if what teams would maybe be issues when I'm just purely looking at attendance? Yeah.
More open stadiums during like inclement weather times?
So for sure, if I don't control for things like weather, yeah, there for sure is going to be systematic correlations with things like that. But the one big one we're doing with attendance is if I think about a team that sells out every game, what's the opportunity for growth? Zero, right? So even though we found some negative results there earlier, well, maybe some teams did see a decrease in attendance, but if other teams weren't already at capacity, maybe they would have seen large increases, right? So anytime we're dealing with attendance, we have to think more about stadium, like the percent of the stadium that's being filled, right? Is there a change in the percent of the capacity that's being filled? That way we're kind of controlling for the fact that maybe some of these teams are hitting their, right up against this maximum. Or if I had something like ticket prices, that would also be a good way, the combination. So I kept you guys a little bit over. So I'll let you go on. See that second homework up there on Canvas. It'll be due like not for a while, so you'll have quite a bit of time to work, about 2 weeks. Get your project proposals turned into Canvas by the end of the day tomorrow. Like I said, doesn't have to be real long, a paragraph, a couple sentences, just to give you an idea of what the topic and question you're thinking about going into is. Okay? All right. Have a fun, safe weekend. I'll see you guys on Tuesday.
Listen, you know, see about